All right, so earlier in this class, we defined the 6 trig functions. We defined sine, cosine, tangent, and the other 3. We defined those using the unit circle, didn't we? Another way you can define the trig functions is using what's known as right triangle trigonometry. So I'm going to draw a right triangle. What's a right triangle? It's a triangle that has a 90-degree angle. That's known as a right angle. And then this angle here, I'm going to call this angle theta. Quite often we use Greek letters to represent angles, so I'm going to use the Greek letter theta. What's this side right here called in the right triangle? This is called the hypotenuse. How do you know that one's the hypotenuse? It's always the longest side. It's always the one that's opposite of the right angle. Okay, so if this is our angle theta, this side over here is quite often called the opposite side. It's opposite from where our angle is. Our angle's here, that's opposite. And this side is called? This one's called adjacent. All right, and then here's how we define the 6 trig functions. Then we'll talk about SOHCAHTOA, whatever that means. I don't know what that is. Sine theta. What's sine of theta? It's the opposite over the hypotenuse. And what's cosine theta? Adjacent over hypotenuse. And tangent theta? Opposite over adjacent, which turns out to still be sine over cosine if you work that out. Opposite over adjacent. And then the other 3, just flip them, just like we did before. So cosecant theta is hypotenuse over opposite, and secant theta is hypotenuse over adjacent, and cotangent theta is adjacent over opposite. All right, so I heard somebody use the word already. SOHCAHTOA. What's SOHCAHTOA? No, it's not some like Indian princess. No, that's Pocahontas. Correct. So what's SOHCAHTOA? All right, so these are mnemonics to help you remember. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So I've heard people remember it as SOHCAHTOA. I've also heard people say, some old hippie caught another hippie tripping on acid, to help remember those, the order in which those come in. SOHCAHTOA is better?
My old teacher said, some old hillbilly caught another hillbilly taking over Addison.
Some old hillbilly caught another hillbilly taking over Addison. That's a new one. I hadn't heard that one before.
He's from Addison.
He's from Addison. Okay. Any others? Look online. There are many others. Some of them quite dirty. I can't say those in class, but that'll make you look them up now, right? So, anyway, there are lots of other mnemonics for these. All right, so we're going to be looking at problems like this. Solve each of the following triangles. What does it mean to solve a triangle?
You want us to find the sine, cosine, and tangent function?
Not really. To solve the triangle doesn't mean to find the sine, cosine, and tangent, although we're going to end up finding those. We want to find the lengths of all the sides that are missing and the angles that are missing. All right, so the angles should be easy. If this is a right angle and this is 52 degrees, then what does this one have to be? 180 minus 90 minus 52. So I grab my calculator, I do 180 minus 90 minus 52. This one has to be 38 degrees. Okay, and then I know this side already. This side is 35. How would I find maybe this side right here? I'll call this one H. Why did I call that one H? It's just the hypotenuse. How would I find that one?
Wouldn't you have to do like
35 over 38
But don't you have to, when it comes to, if you want to find something, you have to do things that aren't there, so you have to do tangent theta, to do opposite of adjacent. Doesn't have that opposite.
No. I want to use what I know. I was given that this is 52, and I was given that that's 35. That's the information I want to use. I always want to use the given information. So if I'm dealing with 52, what side is this, the 35? Is it opposite? Is it hypotenuse? Is it adjacent? That's the adjacent. So I've got 52, I've got adjacent, and I want to find hypotenuse. So adjacent, hypotenuse. Which one uses adjacent and hypotenuse? Cosine. Cosine uses adjacent and hypotenuse. So I would use cosine 52 degrees is adjacent, which is 35, over hypotenuse, which is what I'm trying to find. And then I need to take that equation and I need to rearrange it so that it has the h all by itself. Well, how do I rearrange that equation so the h is all by itself?
H equals 35 divided by 27.
I can think of this as being over 1, and I can cross multiply. H cosine 52 degrees is 35, and then I divide. So h is 35 divided by cosine 52 degrees. And then I grab my calculator, and I'm going to type that in. But before I type that in, I need to hit the mode button and make sure that I'm in degrees. And this is going to be a very common mistake at this point. We're going to be using both degrees and radians. If you're using degrees, make sure your calculator's in degrees. If you're using radians, make sure your calculator's in radians. Very easy mistake to make. Alright, so then I type in 35 divided by cosine 52. And I get, I'm going to round to one decimal place, I guess, 56.8. Alright, so now I know h up here is 56.8. What about the last side? How am I going to find that? I could use the Pythagorean theorem. Absolutely, I could do a squared plus b squared equals c squared, but I'm not going to. And here's the reason why. This 56.8, this is something that I figured out. What if I made a mistake? And then I'd mess both answers up, wouldn't I? So what I really prefer to do is only ever use the given information if I can. So I'd much rather somehow use the 52 and the 35 if I can. So this thing over here, this would be opposite, wouldn't it? So to find this side, I really want to use tangent. I want to use tangent of 52 is opposite over adjacent. Would it be wrong to use the Pythagorean theorem? No, it's just a little risky. If you made a mistake and then you use that data, if you use the 56.8, then and that's wrong, then you're guaranteed that that one's going to be wrong too. That's just a bad idea. And the other thing is we rounded this off a little bit. You always want to avoid using rounded off numbers if you can. So I would much rather prefer to do tangent of 52 degrees is opposite over adjacent, which is 35. So opposite is multiply both sides by 35. 35 tangent 52. 44.8 rounding to one decimal place. Questions on that? All right, how about the second one? We're given a side here. This is 73.2. We're given an angle. This is pi over 6. Well, again, finding the third angle should be easy. What does the third angle have to be? How'd you get pi over 3? Okay, so what she said is, when I add up all three angles, what do they have to add up to? Well, all three have to add up to 180 degrees, which is pi. But this one's already 90 degrees, which is pi over 2. So the two that are left have to add up to pi over 2. So we have to have pi over 6 plus whatever that third angle is, has to add up to pi over 2. And then she subtracted pi over 6 on both sides. So pi over 2 minus pi over 6. And then you got a common denominator. That's 3 pi over 6 minus pi over 6, which is 2 pi over 6, which reduces to be pi over 3. She did all that in her head. That's pretty good, huh? Pi over 3. All right, so before I go any further, I'm going to grab my calculator and go mode and go back into radians so I don't forget to do that. Because I clearly see I'm working in radians in this problem. All right, which side do you want to find next? The hypotenuse, all right. Which one's the hypotenuse? The one down on bottom because it's opposite the, what you call it there, the right angle. Okay, so what am I going to do? So this is adjacent and hypotenuse? Oh, it's the other way around. This is adjacent. This is hypotenuse, correct. My triangle's kind of upside down there. So I'm going to have cosine pi over 6 equals 72.3 over h. And that's just like we had last time. So when you solve, you're going to get h is 72.3, I mean, divided by cosine of pi over 6. What's cosine of pi over 6? 1/2? No. 0? No. 1? No. Root 3 over 2? Yeah, root 3 over 2. 72.3 over square root of 3 over 2. Well, that doesn't help me very much. I'm just going to use my calculator anyway. 72.3 divided by square root of 3 over 2. I get 83.5. 83.5 is what I got. But 73.2? Yeah, that'll do it. 72.3. All right, and then again, to find the other side, I think I would use tangent. So tangent of pi over 6 is going to be the opposite over adjacent, 72.3, which means our opposite side is 72.3 tangent pi over 6. What's tangent of pi over 6? I think I heard two correct answers. I heard square root of 3 over 3, and I heard 1 over square root of 3. Those are both correct answers. One's rationalized and one is not. I got 41.7. All right. Now, let me ask you a question. how is defining these trig functions in terms of a triangle the same or different from what we did when we defined them using a unit circle? Are they the same thing? Well, they better be the same thing if we're calling them sine and sine and cosine and cosine, right?
Because it would just be one of the, it'd be one quadrant.
All right, so let me draw you a unit circle. Here's a unit circle. On the unit circle, if I picked a point right here, x comma y, and we called this arc length right here, we called this arc length t. So we said sine t is, how did we define it in terms of a unit circle? Sine was y. And cosine t was x, and tangent t was y over x. All right. If I draw this line right here, keeping in mind that this is a unit circle, what's that angle right there? Certainly less than 90 degrees. That's true. I want an exact answer for it. It's not 6 feet. Well, maybe it's 6 feet, but it's not necessarily 6 feet. Theta, okay, we could call it theta. Theta is exactly the same as t. Why is theta exactly the same as t? Because we had a formula for arc length back a few sections ago. The formula we had for arc length back a few sections ago was S equals R theta. S in this case, I called it the arc length, that's T. What's the radius of that circle? Well, it's 1 because it's a unit circle. So whatever that angle theta is, that angle theta is exactly the same as the arc length t. So instead of using t here, I could have used theta. They're the same thing. T and theta are equal. All right, last thing. What if I draw this right triangle right here? If I draw this right triangle, what's the sine of this angle theta using the triangle? Sine is opposite over hypotenuse. All right, if this is my angle theta, how tall is the opposite? It's y. This distance would be y, correct? And what's the hypotenuse? It's a nice number. It's bigger than 0 and smaller than 2. Why is it 1? This is the unit circle, so this hypotenuse is the radius of the circle, isn't it? So thinking of it in terms of a triangle, sine theta is opposite, which is y, over hypotenuse, which is 1. I get exactly the same answer. So the right triangle definition and the unit circle definition are really exactly the same. Except we're thinking of two different measurements. When we're dealing with right triangles, we're measuring based off the angle. When we think of unit circle, we were measuring based off the arc length. But it turns out if you're dealing with a unit circle, the arc length and the angle are exactly the same. And because the hypotenuse is 1, you get exactly the same answer. Same thing would happen with cosine theta. Cosine theta would be the adjacent, which is this length. This length is x, divided by the radius, which is 1. Get the same answer. So there's really no difference. Except that if I'm dealing with a right triangle, I can only deal with acute angles. I can only deal with angles between 0 and 90. Where using the unit circle, we were able to talk about any angle we wanted to. So the unit circle gives us more than the right triangle does. All right, right triangle trigonometry is one of my favorite things in the whole wide world to teach because it really has many, many uses. And we'll do some word problems here that I copied out of the book, but let me give you a problem that I had to answer a few years ago. A few years ago, my house was right there. So this is looking at it like you're in a helicopter. So you're looking down from the top, so you're seeing the roof. Right over here was a dead tree. And I was afraid on a real windy day like today that this tree was going to fall down. So I wanted to cut that tree down. The problem I had was that my neighbor's garage sat right here. The tree could not fall that way. It would fall on top of the garage. No way around it. My other neighbor has a fence that goes right along there. So the tree couldn't fall that way because it would crash over the fence. And then there were a bunch of other trees along here. So the tree could not fall that way because it would just hang up in the other trees. The only way this tree could fall was right toward my house. And what was I worried about? I was worried about it hitting my house when it fell. Okay? So here's what I did. I'll draw a new picture here. Here's the tree. Yes, I have very limited art skills. There's the tree. And I walked backward from the tree. I got a long tape measure, and I measured back 40 feet. And then I took a protractor, and I held it up, and I found this tree right here. And this angle happened to be 82 degrees. How tall is that tree? Well, what do I have? I have this angle 82. And then what's this side? The side is adjacent. And what do I want? I want this length here. This is opposite. So I have angle, I have adjacent, and I want opposite. What uses opposite and adjacent? Tangent. So I went tangent of 82 degrees equals opposite over 40. So the length, the height of that tree was about 13 feet. Did you make sure you pushed mode and went back to degrees? Ah, see, I told you that would catch you at least once this semester. All right, so
284 feet.
40, tangent 82. I get 284 feet. All right, so the truth is, I don't think the tree was that tall. I forgot what the numbers were that I used. But I can tell you what it came out to be. It told me that if I fell the tree right towards my house, it should be about 3 feet short of hitting my house. So what did I do? I hired somebody to climb up the tree and cut the top off and knock it down because I was, my calculations here were pretty rough. I mean, holding a protractor up and looking and saying, oh, that's 82 degrees, that's 82. That's pretty rough. It was going to be very, very close to hitting my house, so I hired somebody who climbs up trees and cuts the tops off and falls them down and took the tree down safely.
So did that have to fall?
I had it cut down. It didn't fall.
Completely cut down?
Yeah.
Okay.
I didn't have it derooted. They came in with a grinder and they ground the stump down. But the roots were still there, so eventually the roots rotted and it kind of sunk. And you just get dirt and you fill it back in. It's not a big deal. Anyway, it came out really close. It was within a couple feet, and I wasn't willing to take the chance on my arithmetic that it was not going to hit my house, so I hired somebody to knock it down for me. Anyway, here are some other good examples of where we use right triangle trigonometry. Number 2 is pretty much the same question that we just did. The angle of elevation to the top of the Empire State Building in New York is found to be 11 degrees from the ground at a distance of 1 mile from the base of the building. Determine the height of the Empire State Building. Well, that's pretty much the exact problem we just did. You have the Empire State Building. It looks like that, of course. We're 1 mile back. And the angle of elevation, which would be this angle, they told us that's 11 degrees. I should draw like King Kong sitting on top of the building. But all right, so how tall is the Empire State Building? Well, what would you use? Tangent again, because we want this side over here. This is the opposite side. We have the adjacent. So we would have tangent 11 is opposite over 1. So the opposite side, the height of the building, is tangent of 11 degrees, which is 0.194, and the units on that would be miles. About 0.2 of a mile tall. That's pretty impressive. How many feet is that? How many feet in a mile?
530.
5,000.
What's that?
Are we talking about?
5,280 feet in a mile. That's correct. So I would multiply this number by 5,280. So it's about 1,026 feet tall. About 5,280 feet in a mile. So we all live in the feet, inches, miles, units, right? Shouldn't we all know that? No, we shouldn't. No. How many meters in a kilometer? See that? See, metrics is easy, isn't it? Just multiply by powers of 10. So it's our crazy system that's hard. All right, a 600-foot guy wire. What the heck's a guy wire? What's a guy wire?
Say that you want them.
It's just a wire that keeps it from falling over. Okay. So we have a 600-foot guy wire is attached to the top of a communication tower. All right, so we have a tower. This is the tower. And what they're telling us is we have a wire coming off the tower, like so, and this wire is 600 feet long. Why it's called a guy wire, I don't know. If the wire makes an angle of elevation of 65 degrees, how tall is the tower? Very good. So a lot of students tell me, I don't know if I should use sine or cosine or tangent. How do I know which one to use? And it depends on what you have and what you want. That's exactly right. So this time you got to look at what we have. We have this angle. We want opposite. We have hypotenuse. So if you have angle opposite a hypotenuse, what uses opposite and hypotenuse? Sine. So in this problem you want to use sine. Why did we want to use tangent in this problem? Because we wanted opposite and we knew adjacent. So it all depends on what you have and what you want, which of the functions you use. So you got to draw the picture and figure it out. There's no set way for each problem. Sine of 65 is going to be the height over 600. So the height is 600. Sine of 65. I'm told that that's 543.78 feet. When you do your homework on WebAssign, it will normally tell you how much to round off to. So it will, my guess is on this problem it would say round to the nearest foot. So if you're doing it on WebAssign, read the directions, but my guess is you would probably give 544 feet. Well, it's accurate rounded to the nearest foot. It's only off by, 0.22 feet, a couple inches. It's not very much. Follow the directions on the sign. That's all I'm saying, so that you don't get the problem wrong. All right. If the flagpole is 60 feet tall, how far is the woman from the flagpole? So this time they're telling us this distance is 60 feet. You have to find both of them separately. Who are them?
So you want, like, you do two separate ones and you just add them.
All right, so we're going to have to do two separate ones. So we're going to have to do this one, I think, and we'll give that a letter. What letter do you want to call that? B. And then we have to find this one, and that one we're going to call C. So we know that B plus C has to be 60. All right, but now we've got to rewrite B and C using this letter X. And we're going to use tangent, because tangent of 18 would be opposite, which is B, adjacent, which is X. So I agree with you. I think we want to use tangent of 18 degrees equals B over X. So B is X tangent 18 degrees. And how about for C? Still going to use tangent, aren't we? Because for 14 degrees, C is the opposite. X is still the adjacent. So tangent 14 degrees is C over X. So C is X tangent 14 degrees. And this happens sometimes. Sometimes you have to use more than one triangle to figure out these answers. All right, so final answer looks like X, our final equation, tangent 18 degrees plus X tangent 14 degrees equals 60. How to solve that equation? Factor out the X. There's an X here and an X there, so we factor it out. X tangent 18 degrees plus tangent 14 degrees equals 60. You figured it out, Brandon? I did it differently? Okay. So X is, to get the X all by itself, I divide by that mess there. So I'm going to have 60 divided by, parenthesis, tangent 18 plus tangent 14. My calculator says, rounding to one decimal place, she's 104.5 feet away from the flagpole. All right, last problem. To estimate the height of a mountain above a level plain, the angle of elevation to the top of the mountain is measured to be 32 degrees. 1,000 feet closer to the mountain along the plain, it is found that the angle of elevation is 35 degrees. How tall is the mountain? All right, so we've got a mountain. And we've got a plane. So, what does it say? What does it mean when it says the angle of elevation to the top of the mountain is 32 degrees? If I'm standing here and I'm looking at the top of the mountain, that angle right there is 32 degrees. Then it says we moved 1,000 feet closer. So this distance is 1,000 feet. and I remeasured my angle, and I got 35 degrees. What do people use to measure those angles? That's a great question. That's why I asked it. Yeah, you could use a protractor. Usually they have a really fancy protractor, though. Yeah, one of those survey machines. So you'll see sometimes if you're driving along the road, they'll have these tripods, and they'll have a thing on top, and the thing swivels, and it moves up and down. For the life of me, I can't think of the name of what one of those things is called right now. A transit. It's called a transit. I'm sorry. I found it. So they use something known as a transit, which very accurately measures angles. You use that a lot in building construction when you're first building a foundation to make sure you got the foundation square. That's a big thing when you're building a house, that you have nice square angles. Anyway, so somebody used a transit to measure these angles. What are we going to do? There's my right angle right there. There's the height. That's what I'm looking for. Any ideas? Well, I'm assuming that it does too, or they wouldn't have given it to us. I want to use this 35, and H would be...
Oh, would we work it out so that we would do 32, and we would use that as our opposite adjacent, and we would subtract the 35 from that?
Yeah, that's exactly what we're going to do. The problem we have is we don't know that distance, do we? We'll call it X. That's a good number. X. So, using this, I know that tangent 35 degrees is H over X. And what would I know about 32 degrees? All right, so tangent 32 degrees would be opposite, which is H, divided by, not 1,000.
1,000 plus X.
1,000 plus X. Why is it 1,000 plus X? It's got to be the entire distance. It's got to be that entire distance, which is 1,000 plus X. All right, so what we end up with is we end up with two equations containing two variables. We end up with a system of equations more complicated than the kind you did in Math 1412. How would you solve that? So for example, this one, H is X tangent 35. And then put that into there. All right. So tangent 32 degrees is X tangent 35 divided by 1,000 plus X. All right, so that's better. So now that equation only has one variable and it only has the variable X. You can work with that. But now how do you solve that equation? How do you get the X all by itself? Multiply? All right, so this is 1,000 plus X times tangent 32 degrees equals X tangent 35 degrees. And then I'm going to go ahead and distribute. I'm going to take this tangent 32 and distribute it through. So 1,000 tangent 32 degrees plus X tangent 32 degrees is X tangent 35 degrees. Now what? not divide. What would you do if you had like 3x on this side and 5x on that side? You would subtract. And these are really just numbers, tangent 32, tangent 35, they're numbers. So this is like having a 3x over here and a 5x over there. You would subtract, except when I subtract, I can't really combine them. I can write 1,000 tangent 32 degrees equals x tangent 35 degrees minus x tangent 32 degrees. And then it's like the problem we did a minute ago where we had an x and we factored it out. And that's exactly what we're going to have to do here. So 1,000 tangent 32 degrees equals x times tangent 35 degrees minus tangent 32 degrees. And finally, I can use my calculator. X is, type it in, 1,000 tangent 32 divided by, make sure you put these in parentheses, tangent 35 minus tangent 32. I get x is 8,294. And that would be in feet.
So you took the tangent 35 minus tangent 32 and divided that by or you divided by 1,000.
Right, so what I did on my calculator is I did 1,000 tangent 32 first, so I did the numerator, and then I said divided by, and I put it in parentheses, tangent 35 minus tangent 32. Still not done because that's not the answer we want. What we want is the height, so we're going to take that x and we're going to plug it back up in there. So we're going to take 8,294 and we're going to multiply it by tangent 35. And our final answer is, that mountain is 5,807 feet. So just short of, just a little more than a mile tall. 5,280 feet would be a mile. Just over a mile. So. Questions?